numbers. On an Argand diagram, shade the region whose points represent complex numbers z which satisfy both the inequalities. The modulus of z minus 4 minus 3i is less than or equal to 2, and the argument of z minus 2 minus I is greater than or equal to pi over 3. So first of all, this is a circle because we use modulus and we have z on one side only. To find the center, we have to make it z minus z1 form. So notice that if we multiply, we get minus 4. If we multiply, we get minus 3i. So we are not changing the question, but we can see the center now is 4, 3. The radius is 2, and smaller than means we shade inside the circle. So for the circle, you have to label the center of the circle, and the radius is 2, so it's supposed to be kind of like this. Now for the second locus, this is argument something. Actually, it's not perpendicular bisector. Okay, so argument something, this is called a half line, right? So it's called a half line. So half lines start from one point and the line goes forever in one direction. So here we have so we have to express in z minus z1 form, and if we multiply we get minus 2. Here back to this, and if we multiply we get minus I. We're not changing the question, but we can identify the starting point of the half line, which is 2, 1. So 2, 1 is around here, and the angle is greater than pi over 3. So the angle calculation starts from this point to the positive x direction or positive real direction. So from here, this is the 0 degrees, this is pi over 3, and so on. So this is the angle from positive x-axis. Since the angle should be greater than pi over 3, we start from here. Greater than means we go in this direction until the maximum angle, which is pi. So we don't go in this direction all the way to 360 degrees, but only until pi, because we use 0 to pi only. And for this kind of angle, this is actually from 0 to minus pi. Okay, so only from pi over 3 to the greatest value is pi, not all the way to 2 pi or something. Okay, so the principal axis is from minus pi to positive pi. So the combination of the two graphs, we draw the circle and the half line, and we only shade the part of the circle inside the circle, but also in this shaded part. So the intersection is this area. We're gonna need to label center of the circle and the starting point and the shaded part, and yeah, that's it. Now calculate the greatest value of arc z for points in this region. So the z is the point, so it's like the line from the origin, a line from the origin to any point on the shaded area. So the shaded area is around here, so the line can be like this, so to any point on the shaded area. Since we are looking for the greatest arc z, this means we need this line to have the biggest angle theta. So that happens when the line touches the circle. Touching the circle means this tangent line should be perpendicular to the radius. Now if you look at this triangle here, we get this kind of triangle, and for this triangle here we get this kind of triangle. Okay, so we are drawing this triangle and this triangle. This is what we draw. So from this triangle we know that this distance is 4, so it's 4, and this distance is 3, so this is 3. And from this triangle we know that the radius of the circle is 2. So for the alpha, we can use tangent. Tangent alpha is opposite over adjacent, so the alpha is inverse tangent 3/4. And using Pythagoras, we can get the hypotenuse of this triangle, which is 5. And now if you want to find the angle beta, we can use sine, because sine beta is opposite over hypotenuse. We can find the beta, which is inverse sine 2 over 5. Now that we have the alpha and beta, we are looking for theta, so we add alpha and beta. Use your calculator, inverse tangent this plus inverse sine this, you get 1.06 in radians. Alright, I'll see you again next time.